Welcome to a new test and teardown video. I just came home from a flea market and I got some really cool things. This one is a frequency counter called Lubacount 525. It was made by OZ9OG Otto. Probably back in the 70s or something like that. If I am not mistaken, look at the displays. I would say that is minitrons, numitron. They're from Fuji, and the number is 3015F. They're filament bulbs kind of displays. And they're nice and bright and shiny and super good. So I really like them. I desperately hope this instrument would work. So it's gonna be fun to play with. Let's try and power it up and see what happens. I grounded the chassis just in case, because the mains connector here is without. Ooh, look at that. Let's turn off the... I saw some light. And it went away. Let's try and turn it on again. Yes, it goes on and then it turns. Did you see this? Why isn't that possible to see from the front? Yes, it is. What is this? What is this good for? So, oops. Well, I maybe should try and fix the power supply. It's using a lot of power. So instead of blowing this up, I should maybe open it and try and fix it. It is really some kind of homebrew. Wow, look at that, huh? So that PCB with all the counters, latches, and 7-segment drivers. See, 7490, so that's count by 10. And then the 7475, that's latches. And this is of course needed for a frequency counter. You want to latch and then you want to count and then latch again and again, right? And then I think we can find 7474. No, 7447. Those are 7-segment drivers, and they're capable of driving the minitrons, because the minitrons only needs a few milliamps. So that's quite alright. I think they're a little bit overloading those chips. And then we got a crystal. And a crystal oscillator with NAND gates and counters and a lot more counters. That is of course to make it down to milliseconds or to seconds, depending on that switch. See, it says kilohertz or hertz. So that is definitely the two different outputs from that counter. It's a little bit funny. This is ground. So then this signal enables something and then it goes into this system here. Got some different frequencies going on here. So this is probably where we select the different latch signals. It goes, I don't know. I'll go and measure this a little bit and figure this out. And that will be the input signal goes here, and then there's a 10K resistor. Oh, we got a little field effect transistor and then a normal transistor and some trimmers and stuff to make this, yeah, I don't know how fast this will go really, but it's looks like a lot of experimenting was going on in this area, and probably a little IC for cleaning up before it continues. Maybe this is the output that goes to the counters. Yeah, that's probably what it is. This is a very, very cool do-it-yourself kind of experimenter project, but I kind of like it. It's really, you know, I have done a lot of stuff that looks exactly the same, I must actually admit, you know. So, well, that one looks like it's not connected. Look at that. So this wire here, well, yes it is actually, but barely connected to that one. Even this transformer is a reused part from something else, and see, we can even see the marking lines for drilling and bending this part here. And this case is actually a very cool case for do-it-yourself kind of projects. You don't need any screws to open it. You just pull the sides out. They just slide in here and then they go stuck. That's actually quite nice. And then you have your plates or your PCBs or whatever. You just take some screws, and then the screws go down and mount your stuff like that. I think it's easier to see here on the other side how that is kind of done. So this is the display board. That's also a home etched PCB, and this one is 2 millimeter thick. So it's really a thick. Oh, there's only one wire to this switch, so that explains why this didn't do anything. So that was a magic, let's try and this and that kind of switch. Maybe there's a magic wire missing. I haven't yet seen any loose wires. So that's probably just the power supply transistor. And that is a power supply measurement point. Let's look a little bit on the other side. Again, here is the display board. Quite nice. This is okay. So the output is only 6.3 volt AC, and this is rectified by 2 parallel bridge rectifiers. And then I don't know how they did this, but there's probably a voltage doubler somehow here with this capacitor, right? And maybe there's a diode down there. Maybe that is how it works. And then there is a transistor, a diode, and a Zener. And then the output transistor. There's no feedback on the voltage. So this is the output voltage directly from that transistor to this capacitor. And then here we go. All the red wires here, they go to all the different boards except that wire here. This one here. That is some other voltage that goes somewhere else. Where is that going? That goes to the input board. I better power this up again and measure a little bit here. What is going on? We got some funny things with those wires and whatnot. Yeah, this is a very cool experimenter, play around kind of thing, right? Yeah, I was right. So this is the voltage for the input circuit, and we've got 2 volts per division, so this is 8 volts for the input kind of board. And if I measure here, see, that will be the 5 volts. We've got about 5 here, and look at that. So this is the ripple for the 5 volt supply. It's probably not a big deal. It is more or less within specifications, then there's no high frequencies or anything nasty on that. So I'm running at 230 volts. Let's go down to 220. Yeah, and it's still about 5 volts, so that's all right. Oh, I don't know. Look at that. We are now in hertz. So this is 12,345. Look at that. What the heck? And this thing is from 1973. I've been looking at all the ICs, and the newest one is from 1973. And it still works. Of course, measuring kilohertz, or I mean hertz like this, is of course possible. And if I go all the way to kilohertz, yeah, see, here you are. Ooh, we have a little bit of a stuck driver here. And if I remove the input signal, then it turns off to save the displays, and then it counts. So there's an input signal detector, and then power off after 1 second. How cool is that? The only digit that is on is the decimal, like that, and this way you know the unit is powered on. So it actually works. How nice. Let me see if I can figure out if there's any other digits or anything else that is causing a problem, but I definitely see. Okay, so that was a 5. Let me go and make this one a... that doesn't help a lot, because then it's still on. Oh, that digit is always on, except for 2, right? Like that. Okay, so here is not a problem. What if I... Then it goes on. Really? So there's some other problem. But those are beautiful. The numitrons. Super high contrast. I totally love them. And I got enough to make a clock or something. That is a winner. And it was definitely a super nice do-it-yourself kind of project here. Very old. So I bet the good old Otto had a lot of fun hours making this one work. Hey, how about we test how fast can this go? Should we do that? So of course we should go directly to kilohertz. And let's just crank up the kilohertz like that. It's 20. I'm gonna remove all my other digits to 0, and then we're gonna go back to kilohertz. So that is 100 kilohertz. Okay, we're gonna crank up the... Ooh, so that is 1 megahertz, and then it starts to blinkety. Aha, that's something funny. Why is it doing that, by the way? And I don't know if you can see this, but this the update speed here is definitely that fast. I know now what it is. See? It is because... See? it is updating that fast. It is of course running in millihertz or in milliseconds, the update speed. There is no like wait, so it just refreshes at that speed. So this is actually 11 megahertz. Oh my, okay, then 13 megahertz. Okay, then it starts to go berserk. But this thing can do 13 megahertz. How cool is that? I did not expect that. Alright, 13 megahertz done in super duper DIY in 1973. How nice. Alright, this is all I wanted to say in this video. I hope you had a little bit of fun, and see you soon. Bye bye.